So, today we're considering the thoughts of one Paul Feyerabend, whose belief was that we've been trying all along to come up with some very careful set of rules or standards, beliefs about what makes science a good thing, what makes something good science, to come up with sort of ways of rationalizing and supporting our scientific beliefs with sort of good methodologies. And Feyerabend says, nuts to all that, do whatever you want, and we'll all be better off. Feyerabend's belief is that the only principle that does not inhibit progress is anything goes. So this is his methodological or epistemological anarchism. That is, not that everybody would be better off doing random stuff, but that there's literally no principle whatsoever that you can say that we're always better off following. There's no rule, there's no methodological or epistemic rule that should run throughout scientific methodology. Science would make more progress, people would be happier, society would be better run if we didn't have such rigid faith in strict rules and methodologies. That's his claim. Now, if you weren't here last time, I contextualized that claim a little bit by pointing out that Paul Feyerabend's role, his goal in writing this book that this claim comes from, Against Method, was to say the most inflammatory thing that he could think of saying, and the goal was to have a joint publication with Imre Lakatos, who's a much more sort of conservative and staid philosopher of science. Feyerabend was going to write Against Method, and Lakatos was going to write For Method. The book was going to be For and Against Method. Lakatos died, so all we get is Feyerabend's slightly unhinged and very extreme view. But he makes some points. I gotta say, he makes some points. And the points that he makes are drawn primarily from the history of science. So he says, look carefully at the history of science. Look at the moments when we made the most progress. These points where there was just unambiguously clear forward movement in our understanding of the world. And if you look not at the kind of facile, heroic versions of these stories, but the details of how it actually went down, what you find is that the main actors very often broke the established rules. The people who made these great leaps really didn't have that much respect for the hardline scientific methodology, especially the hardline scientific methodology of their time. And Feyerabend's going to make the even strong. So there's two claims that he could make here. One, break the rules that exist at your historical moment. Two, the much stronger claim that there simply are no rules that are going to be reasonable to follow all the time. So therefore, break the rules is the claim. Or at least feel free to do so when it suits you. That's the view. Today we're going to look in some detail at one of his main historical examples, the Galileo affair. So I'm going to go through that in a little more actually historical depth than Feyerabend gets into it, because I think the details are interesting. I think looking at it in his historical context gives us a richer picture of what was going on in Galileo's time, and gives us a more complex view of this sort of moment in the history of science. So I'll do a fair bit of that today. That's most of the job today. But throughout, what I'd like you to be thinking about is, does this establish the claim that Feyerabend hopes that it does, that he's trying to make with it? So Feyerabend says, look at Galileo. Look at how Galileo violated practically every baseline scientific methodological rule. But of course, we all think that Galileo did a good thing. Therefore, break the rules. So that's the central argument. Keep that in mind as we're going through this stuff. And think about whether you think that argument sticks or not. Because, again, as I said last time, Feyerabend explicitly tells us that he doesn't believe all this. He explicitly tells us in the book and in interviews afterwards that he's kind of just trying to stir up trouble. He does think that it's the kind of trouble that we need. So he does actually believe that people are, especially with respect to science, and especially with respect to science in the 1970s, I would say, people were excessively deferential to the authority of science, that people took it and themselves too seriously, and that we would have a better relationship with the authority of science if we had a little more play and creativity and free thinking going on. It's a very 1970s sort of thing to think. Again, this was before it became very obvious that the climate catastrophe is going to kill us all, and that if we don't listen to scientists, we're doomed as a species. Very few people are, not a lot of people trying to rattle the authority of science these days. As far as I can tell, the flat earthers and anti-vaxxers and climate denialists are the main groups. Not really strong academic opposition to sort of science as an institution, or our trust in science as an institution. So, yeah.
Well, there's some people that describe the period that occurs after Trump seizes power as the post-truth era.
The post-truth, yes.
Where, some of the people within Trump's regime will use the argument that you can't prove that, like alternative facts.
Right.
You can't really prove anything is true. Therefore,
and those of
us
who lived through the George Bush Jr. era think that that's naive, because that happened a long time ago.
What do you mean?
In the George Bush's presidency was also very much post-truth. We've been post-truth a long time. And in fact, we're going to experience some post-truth from Galileo's era, where it's possibly not the case that Galileo was using arguments and evidence in the way that you might hope that somebody does. He certainly wasn't sort of sitting happy with just presenting the facts in an orderly way. That's not what was going on in this case study. So we've had a tenuous relationship with truth for since way before 2016. I'll put it that way. Yeah. Okay. So let's dive in. So Galileo. So he's born in 1564. This is kind of early Renaissance. The world is changing. For a really long time, the only way to become rich was to be born rich. There was a kind of view that there was a natural hierarchy in society. Rich people are rich because God wanted them to be rich. And poor people are poor because same reason. In the Renaissance, sort of the Black Plague happens in the 1300s, a third of Europe dies. That creates a massive labor shortage. People start moving around more. People start moving up the social hierarchy because they're doing things like trade. Banking becomes a big industry. So the economic structure of the world, of Europe particularly, is shifted dramatically in the last couple of hundred years. So things are sort of shaking up. Galileo's born into the nobility, so he is in the noble classes, but his family has recently hit hard times. They're not as rich and famous as they used to be. Galileo's kind of hanging on to the nobility, the bottom ranks of the nobility, just by the skin of his teeth. So he's really sort of like the lowest of the high, you might say. But by the time he dies, he's very rich, very famous. He's mixing with the most important people in Europe. So he makes this sort of stratospheric climb in the social hierarchy throughout his life. Somewhat unexpected for somebody of his rank and position. And we're going to sort of see the story of that, how that happened and how that worked right now. So, Galileo is a good Catholic. This is going to be crucial to everything that comes forth. Galileo was born and died a good Catholic. He was a devout Catholic his entire life. He considered becoming a priest, but his father wanted him to go into medicine because medicine pays better than being a priest. So trying to get sort of like the family back into the sort of comfortably the nobility, Galileo goes to university. This is the University of Pisa. The famous tower is right beside it. And studies medicine, but eventually becomes enamored of mathematics and switches over kind of against his father's wishes to mathematics. We're all glad that he did because he made titanic contributions to the quantitative theory of physics. He made big contributions in mathematics. Galileo ends up being one of the pioneers of the idea of applying mathematics abstractly to the terrestrial physical world. So quantifying things like velocity. Like you can't put a ruler against velocity in the way that you can against other, like a regular physical object, but Galileo uses velocity as a physical, like a measurable physical quantity. So we're all glad that Galileo did some math in university. It should be noted again, because the dramatic end of the story is Galileo's conflict with the church. The universities and the church are not particularly separate at this point. Universities are one of the central things you learn at universities, theology. The universities are semi-independent of the church, but they're deeply religious. There's a lot of priests there. And in fact, the church is one of the biggest, if not the biggest, patrons of science at this point. The church is pouring money into doing scientific research. The basic idea being that we've got two texts. We've got Scripture and the world, the book of Scripture and the book of nature. And you can figure out what God's thinking by reading the Bible or by studying nature. So nature is sort of God's a second message to us, and you can learn about God's beliefs and intentions by looking at nature. So the church is deeply invested in this. Most scientists are priests. The church is funding a lot of scientific research. They are by no means anti-science. They're anti-people getting mouthy with them, but they're not anti-science. Okay. So Galileo bounces between the university, the church, and a third kind of large power that exists in Renaissance Italy. So he starts off in the university, he gets a good job, he's got a really good relationship with the Jesuits. So if you don't know, the Jesuits are like the intellectual ninjas of the Catholic Church. They're like these ultra-educated, very, very smart. Their job is to be the kind of intellectual wing of the Catholic Church. So he's in good with the Jesuits. He's got, and he spends most of his career in the university teaching math. So he gets a job at the University of Pisa as the chair of mathematics. But that's really not where he makes a splash. Like being a math professor, unlike today when being a professor is huge amounts of money and social prestige. Back then, it was a relatively modest affair. I'm kidding. Anyway. Okay, so back then it was as today, being a professor is a relatively modest affair. You're not going to get fabulously wealthy. You're certainly not going to get famous. You're not going to mingle with the rich and famous as a math professor at university. So math is not one of the more prestigious parts of the university. It's good for adding up things and doing some astronomy. Physics is not mathematical at this point. Science is not mathematical, largely speaking, at this point. They don't have statistics, they don't have calculus, they don't have most of the tools that we use in science today. So math is a kind of noble but slightly useless pursuit. So the place where Galileo actually gets rich and famous is in the courts. So there's the courts of the nobility. There's also, there's courts of like the kind of hereditary nobility, people who were born into the upper social classes. There's also courts of the recently rich. So as I mentioned, the world is kind of being shaken up here. The idea of people becoming rich has sort of occurred to people, and specifically Galileo is going to latch onto the court of the Medicis. So the Medicis are rich, like really rich. They are bankrolling the Renaissance. They are putting out enormous sums of money to artists and artisans, scientists, poets, musicians, all this stuff. So they're just dumping money on Italy because they have tons of it and they want to legitimize themselves as part of the upper classes. Sorry. Yeah, you and then, yeah.
They created the very first bank, the Medicis.
Okay.
I think
it depends what you mean by bank.
It does, but like
Okay.
if you look up the very first bank, they'll point to Renaissance Italy and the Medicis.
Okay, yeah.
I was just curious how they acquired such wealth.
Banking.
Just banking.
Banking, yeah. Yes, you're correct that they're bankers. There's no dispute. There's no dispute that they were bankers.
Economics major.
Yeah.
Trust me.
I mean, I think it depends on what you mean by bank. Okay, but yes, they were early in the banking game, and they made huge amounts of money doing it. And this was not traditionally regarded at that point. Being a banker was not a high status job. So the idea that these people were unbelievably wealthy from doing a traditionally lower status gig was a bit uncomfortable. And the way the Medici smoothed this out was pouring money into the arts and into charity and supporting the cities that they lived in, which sort of made a pretty strong case that they were okay people. You get people to like you by dumping bucket loads of money on them. It works pretty regularly. So this is more or less what they're doing at the time. There's another shift in society that I think is super interesting to think about in this context. So this is a graph from soon to be discredited academic Steven Pinker's book, The Better Nature of Our Angels. So Better Angels of Our Nature, sorry. This graphs time, so the horizontal axis is time, and this is percentage of aristocrats who died from violence. And this is something with, so you might take issue with some of Pinker's arguments in this book. Pinker's overall argument is that per capita violence has been going down for like 10,000 years or something like that. We don't have a lot of data on a lot of things, but we have a very good data on how rich people in Europe died from 1350 to 1800. We kept good track of these people. We know a lot about their life history. So this is one of the most reliable graphs from that book. And there's a precipitous drop. So we go from a quarter in 1400, a quarter of the wealthy died violently, down to, in 1750, less than 5%. So for a really long time, being rich meant, being a rich male meant you're a fighter. Either you participate in wars or you participate in duels. So if somebody slights your honor, if somebody isn't being properly respectful, you fight them in a duel. And a lot of people died this way. So for much of the sort of like history of Europe, being rich and being active in like killing people were synonymous. You know, the knights and the nobility, one of their main jobs was fighting. And we're somewhere in here, 1500s, kind of deep in this decline. So rich people have really lost the taste for seeing their own blood. They're really not as excited about that as they used to be, and they're looking for things to replace that with. So they're shifting away from a lifestyle of really imagine like a quarter dying from violence. That's huge mortality rates. Down to, I mean, it's lower now, but. So one of the things that they replaced this with is debate. So this is an argument from, a lot of this stuff is being taken from a book by Biagioli, Galileo Cortier. He makes the argument that debate has a lot of the same role, social role, that dueling used to do. A lot of the people that died, a lot of the noble people that died in war, but a lot of them also died in these sort of personal duels. So somebody slights your honor, you do this ritualized sort of fighting. And in a duel, there's no shame in losing, right? It's not bad, it's not socially bad for you to have lost a duel. If you fight courageously, if you fight honorably, if you put on a good show, that's all anybody cares about. You know, fight well, you retain your status and honor. You run away crying, people will talk. But winning and losing wasn't the main thing. It was, did you put on a good show? And Biagioli makes the case that debate, as the kind of taste for violence is steadily declining, debate kind of steps in and plays some of the same role. So these courtiers, one of the things, in the courts of the nobility, so they have this court, there's a bunch of sort of hangers-on. If you've seen Game of Thrones, you get this idea. There's some central figures who control the money and power, and then there's a small group of people who get to be their friends, and a much larger group of people who are friends with the friends. So they would do things like bring in some famous or budding intellectual who would present an idea. And then somebody else would bring in their famous or budding intellectual who would debate the idea with them. And this was a kind of linguistic combat that would, Biagioli claims, replace the duel as a form of entertainment, sort of. The thing is, the point of the debate was not, in any sense, to come to the truth. Just in the same sense that the point of the duel was not to figure out who's the best fighter. The point is to put on a good show. Yeah? So these debates that would happen, so you'd have somebody in to present a poem, you'd have somebody in to present a new piece of art, a painting, and then you'd have somebody in to present an idea and somebody else to debate them. And it didn't really matter to the people who were watching this who was right or who was wrong. The people at the center of this are not intellectuals. They don't really care what the truth is. It's not that they don't care what the truth is, but that's not really the point. The point of these was to be a kind of form of courtly entertainment. So putting on a good show, being witty, being charming, being accessible, those were the things that people were really looking for in these things. In just the same way that when you're fighting a duel, if you fight dirty and win, that's not what's good. What's good is putting on a good show. So Biagioli makes the case that the kind of debates that happen in courtly life are much more performance than truth-seeking. Right? The truth is in there somewhere, and people did care. They wanted to be correct, but what they wanted more was for somebody to come and have a stimulating, entertaining, witty, charming conversation in front of them. This would be a form of entertainment, and so for a courtier, what you want to do is bring to the court something that will please and amuse everybody, because that raises your status. If you bring somebody in who does a really good poem, that raises your status in the court. If you bring somebody in that does a terrible poem, you go down. So it's all about kind of the status hierarchy. And if you bring somebody in that performs really well in a scientific or philosophical or theological debate, that raises your status. Somebody in who performs poorly, you go down. And this is the world in which Galileo really makes his mark. So he's labors for 20 years or so as a math prof. He really flies when he gets into this courtly life. Yeah?
Can you still perform well in the debate, but lose the debate as well?
Yes, absolutely. Absolutely. Just like in the duel. So if you act, you're like courteous when the other person makes a good point. If you say something funny when they give this sort of devastating point to your position, but you say something funny and entertaining, you kind of won in a certain sense. Like the stakes are not who proved their point the most convincingly in some objective, rational way. It's who did the best show.
The people who are watching decide who wins arbitrarily, kind of? It's very informal. Yeah, they're not adding up points. It's very informal. It's very, they don't do a poll on who won later. Because again, most of the people watching this they're not scientists or philosophers, or they're random courtiers. They're nobles, they're other bankers, they're people who are just hangers-on. So they're not qualified, and B, they don't really care that much about who's technically right. Yeah.
So like if it was say like a scientific debate or something, and the person who like won the debate, if they weren't as like funny or entertaining as the person who lost, would people still kind of like believe what they said though? Like would it still be considered credible or not really, because technically they weren't as like entertaining?
I think it. I'm not sure. Okay, so I think they didn't really care what the result was that much. What they would have talked about afterwards was who put on the best show, and yeah. Yeah, so they might, that's sort of a separate question from who you believe. So you could say, oh, this guy did a really good performance. I think he's wrong, but man, he was good. And that's the currency that everybody's looking for. Yeah.
Just to provide a contemporary example, I'm sure people in here have seen like posts floating around that say stuff like, oh, I want to see an argument between Simon. That would be amazing. So, those people don't care about sitting there cooking, probably.
Right.
You know, I think it's that kind of idea.
Yeah, exactly. It's the fun of it. They're arguing for the fun of it, fundamentally for the fun of it. It's not that they're completely uninvested in the debate part of the debate, but that's not really the point. Yeah. Okay. So just a little bit more about courtly life. There's this kind of network of what you can call patrons and clients. So the patron has got a higher social status, the client's got a lower social status, and clients would try to get patrons, right? So you try to make contact with a person who's higher up on the food chain than you are, and usually you do this by sending them a gift, some kind of gift. And they come with these letters that are just disgusting to read. They're really gross. They're like such bootlicking, like, oh, your magnificence is so wonderful that I can't even, my humble blah, blah, blah. And it's gross. Anyway, okay, so the client, you can't aim too high as a client, right? You can't go straight to the top of the hierarchy and say, hey, I got something for you, because they'll just ignore you. But if you get it right, if you get the right level, you say, here, I've got this wonderful thing for you. I got a rare flower, or something interesting, something fun, something that you can bring to court and kind of impress people with, then the patron owes the client, and they have to demonstrate that they are equal to the gift. So you've been given a gift by somebody lower on the food chain than you. You have to nullify that debt by giving them a gift back, and that can be a job or some money. Even better, it can be access to somebody higher than you on the food chain, right? So you say, this is such a wonderful gift. You should meet my friend, Fancy Man, whatever the person is, who's sort of like a better contact. So the gift, the return gift would often be in terms of a social contact. Yeah, it's like, you should meet my friend. So people are trying to find ways of impressing their betters. Their betters use this as a way of, they're collecting gifts. That's not bad. You sort of collect gifts from the people lower on the hierarchy than you. You use those gifts in courtly life or whatever to sort of impress other people, and then you sort of even things out by hooking them up some way, you get them a job or whatever. So back to Galileo. So Galileo's working as a math prof, but he's got side hustles. He's got other things that he's doing. He's not satisfied with just being a math professor. One of the things that he uses to get into courtly life is what's called a military compass. So this is not find the north compass. This is aim your cannon compass. So people were not super good at aiming cannons at this point. Cannons are relatively new technology. They did know that 45 degrees is the right angle to start with. That's when the cannonball goes the furthest. You put it at a 45-degree angle. And then you use a machine like this. So you're trying to land a cannonball on somebody you're having a disagreement with. You launch one at 45 degrees and look where it lands. And then you use this thing to try to calibrate, it went too far or it didn't go far enough. So I need to either move forward or angle up or something like that. So it's a tool for doing mathematical calculations for trying to get your cannonballs to land where you want them to land. And this is one of his sort of breakout gifts. So he's done some kind of connecting. He's talked to the Jesuits who have some social status. He's talking to higher ups, cardinals and stuff like that. He's in with the courtly life. He gifts this military compass to Cosimo II, who's the sort of like, he's not running the Medici family yet, but he's the heir to the Medici family. And as a reward, Galileo, so this is the patron, so Galileo is the client, the patron is Cosimo II. Cosimo II invites him to come be his tutor for a couple summers. So he gets this really nice social hookup. So he gets to go hang out with the young Medici, the guy who's going to inherit the Medici fortune when his father dies. So this is a big jump up. This is kind of using this military compass as his in to the Medici family, which was a really good social move. But the one that blew everybody's socks off was his telescope. So contrary to the popular story, you might have heard that Galileo invented the telescope. He didn't invent the telescope. Somebody else invented the telescope. But Galileo was also a really good craftsman. So Galileo did stuff like improve the glass that they used. He improved the way it was built. And he got it from something like 3 times magnification to 30 times magnification. So he dramatically improves the telescope, and then he makes as many as he can and gifts them to as many very prestigious, wealthy people as he can. So he's trying to gain social status by gifting these things out. People immediately see the value of the telescope. You can do things like see ships coming to sack your city from farther away. You can look at where troops are from further away. People are into this immediately. Galileo's in touch with Kepler at this point. Kepler asks him for one, and Galileo just ignores him because Kepler is not a famous guy. But anyway, he's not okay. So like when we're thinking about the Merton says that the values of science are like disinterestedness and communism. Like if it's mine, it's everybody's. That's not how Galileo's living. This is not his lifestyle. He wants to impress people with his new technology. The other thing that Galileo does with his telescope is turn it to the skies. And he's making observations that nobody else had made at this point. So now we're getting back to his sort of scientific life. So for example, this is a drawing that Galileo does of the moon. And I know that this is, it's not super detailed, but there's something crucially different about this than anything that you can see from the naked eye. You can see mountains and craters. And this was like a big deal. So at this point, Aristotle's picture of the universe is still the dominant picture of the universe. Aristotle says everything above our Earth is made of the 5th element, quintessence. Quintessence is perfect. Of course, the most perfect shape is a sphere. So the moon is a perfect sphere, the sun is a perfect sphere. Everything that's above the Earth is made of perfect spheres. And of course, when you look at the moon, you can see it's not all just one perfect sphere, but the belief was that it was differences in density of the quintessence. So the surface is perfectly smooth. It's just that there's some clumpy bits of quintessence here and less clumpy bits over here. But through the telescope, you can fairly clearly see. He's exaggerated a little bit. It's not this like mountainy, but you can see that the surface is irregular. So this is a major shot across the bow of the Aristotelian worldview. Now, again, the most famous thing that Galileo does in his life is get in trouble with the church. You might think that this got him in trouble with the church. It doesn't. They're fine with this. And in fact, he's fighting with the Jesuits throughout his career for priority for some of these claims. So the Jesuits have also got a hold of a telescope. They're doing things like pointing it at the sun and seeing sunspots. Sunspots aren't supposed to exist because they appear and disappear. In Aristotle, everything's supposed to be unchanging. Everything above the Earth, because quintessence doesn't change. It's perfect. It's supposed to be unchanging. So seeing a sunspot appear and disappear is, again, a big deal. It's a big contradiction to Aristotle's picture of the universe. But instead of suppressing it, the Jesuits were fighting with Galileo about who saw it first. So they're fighting for priority over these kind of like revolutionary observations. Okay. But here's his, okay, this is a really gutsy move. I would like for you to appreciate how gutsy a move this is. Another thing that Galileo observes are the moons of Jupiter. There they are, the 4 Medician stars. There's more moons than that. Those are the ones that you could see through his telescope. Now, the moons of Jupiter, if you watch them long enough, go round and round Jupiter. You can see them moving. You can see them moving in apparently an orbit. For Aristotle, everything orbits the Earth. Everything orbits the Earth. Right? The Earth is in the center. Everything's going around it.
these things are orbiting Jupiter. That's big trouble for Aristotle's picture of the solar system. Okay. So he observes this. He can see them. He's got a pretty good argument that, in fact, these moons are orbiting Jupiter. Profound contradiction with Aristotle's picture of the solar system. And evidence, Galileo is going to make the case for Copernicus' picture of the solar system. Now, Copernicus published this thing 60 years beforehand. So Copernicus is one of the first people to publicly say, hey, you guys, I think the Earth goes around the sun, not the other way around. Copernicus doesn't get in trouble for this at all. People are fine with this. They think it's implausible for some reasons we'll get into, but he certainly doesn't get into trouble. Galileo, at this point, is trying to argue for this because it's a shocking, surprising, interesting kind of idea. And that's exactly what they love at courtly life. However, it's also slightly heretical. Like you're contradicting the official party line of the church. So what Galileo does is name the moons after the sons of the Medici family. He gives them this gift. He says, I've discovered these moons, and I'm going to gift them to you. And you're the Medicis. And what do? You accept this gift? Because then you're kind of saying, Galileo, I believe you. And putting yourself kind of against the church. You're certainly putting yourself against Aristotle, the picture of the Aristotelian solar system. A really risky move on his part. If they said no to this gift, he's out, right? Like this would be a devastating blow to his kind of social status in the courtly life. If they accept, he's in, right? He's got them because they're kind of in on his view of what's going on. They do accept, in fact. Just to give you a taste of the kind of gross bootlicking stuff that they would write in these letters. Since I was evidently influenced by your divine inspiration to serve your highness and to receive from so close the rays of your incredible clemency and kindness, is it any wonder that my soul was so inflamed that day and night it reflected on almost nothing else than how I, your most desirous of your glory, oh my God, I can't even. He's gonna, and hence, since under your auspices, most sincere Cosimo, I discovered these stars unknown to all previous astronomers, I decided by the highest right to adorn them with the very august name of your family. This is typical of the kind of letters that patrons would send or clients would send their patrons, just absolutely just licking their boots, and intensely flattering. But for all this flattering rhetoric, he's putting them in a kind of a tight spot. Because by naming these things, now, the important thing to kind of think about here is that Galileo's using a profoundly new technology. He's kind of the one that comes up with this. He didn't invent it, but he's taking credit for it. There's not a good theory of optics that says why this should work. There's not really a good reason to think that when you're pointing things at Earth, the same principles are going to apply as when you're pointing at things in the sky. So you get these little dots. I mean, Jupiter itself, through his telescope, is a dot. And he's like, look, I see some other dots. If you were a big Aristotelian at this time, what would you say to Galileo? Cool, dots. Maybe your telescope's broken. Right? Wow, dots, they move, huh? Maybe it's broken in slightly different ways. You're telling me that 1,000 years of carefully elaborated theory, well verified by observation, is wrong because you see some dots? All right. But he sent a very flattering letter to these rich people, and they accepted the gift of having these moons named after them. Which is kind of how he gets this accepted into the public discourse. It's really risky. He's really putting his neck out, but he convinces them to accept the gift.
And one of the reasons why, actually, this was a really good, so I want you to appreciate what a good move this was. So, as we said before, the Medicis had made their money at banking. They're looking to, in some sense, mythologize themselves. And one of the ways that they had already been mythologizing themselves was Cosimo I, the father of the Cosimo II that sort of Galileo got in with, had already kind of made a narrative connection between himself and Zeus / Jupiter. So he'd been styling himself as king of the gods. And so naming the moons of Jupiter after his sons fit this pre-existing story really nicely. Like it was a really good move for Galileo. So he's playing into the story that they've been telling about themselves. It's a really, like, self-mythologizing for these people is a big business. They do things like, have paintings made of themselves. They have plays put on about themselves, which they sometimes play in. So like Cosimo I performed in his own court in a play about his family as himself. So telling stories about themselves is crucial to them. And again, they're trying to legitimize themselves in a world that considers the way that they made their fortune illegitimate. So this is not trivial. It's not just vanity. There's really important social reasons why they need a good story about themselves that they can sell to the world. And Galileo takes this bit of a story that they've already got, so they've been slowly identifying Cosimo I with Jupiter. He finds 4 moons of Jupiter. Cosimo's got 4 sons. Damn, that's good. And he actually says that in the letters, he says that these were always Cosimo's stars. These had belonged to him since time immemorial. It was merely Galileo's, he's not really gifting to them, he's just discovering that they were already his. Ooh, it's good stuff. It's good stuff. Okay. We talked a little bit about courtly life. Now let's talk about this thesis that Galileo is stumping for. So let's talk a little bit about what astronomy was like at the time, right? So 1500s, or we're early 1600s at this point, and the model of the solar system that everybody's using is called the Ptolemaic model. So this is from Ptolemy. Ptolemy gets integrated into the kind of broad Aristotelian worldview. When I talk about Aristotle, I'm really talking about the whole scientific research program from like ancient Greece, Rome, the Islamic world, Europe, basically up to the 1500s. So that's all under the heading Aristotle. So this is the Ptolemaic worldview. Here's the Earth in the center. And you can see that the planets are, so these are the planets and the sun going around the Earth. They're doing these weird dippy things. And those weird dippy things are epicycles, because when you look up at the night sky, what you see is a bunch of stars, as you're familiar, I'm no doubt. And then there's the planets that night after night are in slightly different positions. So if you're observant of if you're looking at the night sky night after night after night, you can see the planets moving. And the planets don't just go in a straight line when they're moving. What they do is sometimes they slow down, stop, go back, and then start again. So they do this like start and stop thing. And we know why that is. It's because they're not just going around us in circles, we're going around the sun, and they're going around the sun too. But if you think that the Earth is at the center, you have to build these kind of epicycles in. And the more accurate a picture of the planets you get, so the more data you collect, the more epicycles you have to build into the model to get it to spit out good predictions. So this is not just, I want to emphasize, it's not just they're vaguely like, yeah, the Earth is in the center and then there's planets. This is a mathematical model that is able to predict with some accuracy where the planets are going to be a year from now, 10 years from now, 100 years from now. And they keep feeding in more and more. They keep improving the model. They keep feeding in more and more data, improving the calculation techniques, getting better and better at predicting where the planets are going to be. So this is not, like Galileo's not up against a trivially easy to refute, naive picture of the world. This is an exquisitely detailed mathematical prediction engine that's doing pretty well. It's complicated though. It is quite complicated. You can simplify it significantly. So just before Galileo's time, Tycho de Brahe, I wish I had time to talk about this guy. He's fascinating. He's an eccentric weirdo that poured you can tell he's rich because he's eccentric. So he's fabulously wealthy, and he poured his fabulous wealth into building the best astronomical equipment available at the time. Like, he made observations that were like vastly better than anybody could make because he built these enormous instruments. He also had a fake nose because he lost his nose in a duel. Anyway.
It was a golden nose.
Yeah, he had a golden nose that he would constantly fidget with because he had his lopped off. Anyway, Tycho Brahe, he's a fascinating guy. But he had already produced a novel model of the solar system. So based on his vastly improved observations, the Ptolemaic model wasn't looking so good. And Tycho de Brahe proposed that the sun goes around the Earth, fine, but all the planets go around the sun. So it's a mixed model. So that it's no longer that all the planets go around Earth. The planets, other than Earth, go around the sun, and the sun goes around the Earth. And you get better predictions. So this matches his improved predictions better than the Ptolemaic model. And people are kind of, one or the other, it doesn't really matter. They're okay with either, really. Most people who interact with these systems don't really care too much what the truth is. These are predictive mathematical models. I take it, they tell me that when you learn quantum mechanics today, when you say, what does this term correspond to in reality? They say, shut up and calculate. That was largely the attitude towards these models back in the day. They're like, I don't care what's true. Just this makes the right prediction, so shut up. What they call it, Tychonic system. So it's there's the Ptolemaic system, there's the Tychonic system. There's also the Copernican system. So Copernicus published this thing in 1543. Galileo's active in the kind of early 1600s. So this thing's been around for 50 years. Not really creating all that much excitement, frankly. People weren't too excited about it, but cardinal in the Catholic Church is actually, so Copernicus, I'm sorry to say, was a timid and conservative man. He really didn't like the fact that he was overthrowing 2,000 years of tradition. So he refused to publish for like 30 years. He had this system all worked out and he refused to publish it for like 30 years. He got a copy, the first published copy of his actual book, on his deathbed. So he didn't publish it until he was pretty sure he was going to die soon. But anyway, this thing had been kind of circulating for 50 years. It made better predictions than the Ptolemaic system. It was slightly easier to use. It still wasn't correct as far as we're concerned. So notice that, for example, the orbits of the planets are all perfectly circular. So based on ancient tradition, the belief was that circles are the most perfect shape. That comes from like Socrates, or like the kind of mystical mathematicians of the ancient Greek world. So Copernicus is still of the belief that the planets are moving in these perfect circles. It wasn't until Kepler, who's kind of a contemporary of Galileo, that we get the ellipses that actually makes that roughly are the orbits of the planets. So Copernicus' system also needs epicycles. Remember how Ptolemy needed to add little circles on circles to make his predictions work? Copernicus has to do that too. So his system is not, Copernicus does not, let's say, nail it. He does get the rough shape of the solar system right, though. He puts the sun in the center and the Mercury and Venus inside the orbit of Earth and Earth, and then he gets the order of the planets right. That's not bad. Anyway, so these are the three main sort of pictures of the solar system that are current when Galileo is making his arguments. When he identifies the Medici stars, these are part of his story about why we should become Copernicans. It's the Copernican revolution. He's kind of one of the big advocates for Copernicus when most people weren't that excited about it. The trick is, and this is to remind you that we're ultimately talking about Paul Feyerabend, the trick is that there's some really deep problems with the Copernican picture given what people understood at the time. Some really profound arguments against it. And that's one of the reasons why it didn't generate much buzz. So here's one of the deep problems. If the Earth is spinning round and round the sun, then we should see some shift in the relative position of the stars. It's called stellar parallax. So if you move from position A to position B, suppose that one star is farther away than the other stars, or like this. So you should see the stars shifting with respect to each other, right? Like if I move across the classroom, your positions with respect to each other are shifting. The same would happen if you shuffled slowly across the classroom, I assure you. Okay, so parallax, right? So presumably not all the stars are the same distance away from us. So you should see if the Earth is going around this enormous orbit, like mind-blowingly big for the time. If Earth is going around this enormous orbit, you should see the stars shifting with respect to each other. You should definitely see them shifting with respect to the planets, which are supposedly much closer. So where's the parallax? Given the instruments available at the time, there was no observable parallax. We can see it now because we have really good telescopes. But back then, this is a prediction of the theory that did not materialize. So what do you say about that? Like, oh, here's my theory. Actually, you guys, we thought the stars were like just slightly past the planets. Here's my theory. They're actually some mind-blowingly far distance away. All of them are so far away that you can't even fit the numbers into your head for how big the distance is. Maybe that's it. That sounds ludicrous, right? Oh, I know. We just make the universe like a zillion times bigger than anybody ever thought it could be. Maybe that's why it doesn't exist. See how weak an argument that is? It's really bad. Like, that's a terrible argument. Oh, all I have to do to make my theory work, it makes slightly better predictions, and to make it work, all I need to do is completely change how we think of the size of the universe. No problem. Here's another one. I mentioned this last time. Okay, so not only is the Earth spinning around the sun, but you're telling me it's spinning around on its own axis every 24 hours. The entire Earth is going round and round every 24 hours. All right, cool. So when I drop something off a high tower, why doesn't it zoom off into the distance? Right? Even more intuitively, why don't we fly out? You're telling me the whole Earth is spinning round and round every 24 hours. Why don't we fly off of it? I've been on a merry-go-round. I know what happens when you spin around really fast. You zoom off. So we've got a very clear understanding of what happens when you whip things round and round, very well verified. You can do this experiment as many times as you want. It'll never not zoom off. And you're telling me that the entire planet is spinning around every 24 hours and you don't even feel it. That's a strong argument. It's especially strong because of the state of physics at the time. So for Aristotle, things only move when they're acted on. That was the picture of how physics works. And it's a super intuitive picture of physics. Yeah? Like, there's no moment in our ordinary day-to-day lives where you just set something in motion and it just continues forever. I've never seen that happen in my entire life. Right? Just continues forever with no further force acting on it. I've never seen it. I believe that it's true though, right? So inertial physics says an object in motion will tend to stay in motion unless acted on by a force. The things in our world are subject to friction, and that's why they actually slow down and stop. But very counterintuitive, right? Like you have to go to space to actually see this happen. Now, Galileo is one of the early developers of the inertial theory of physics, the idea that things in motion tend to stay in motion. But he's wrong about, it turns out he's wrong about inertial physics. He presents what's called circular inertia. Things moving in a circle will tend to continue on in a circle. So if I go like this and let go, it'll continue on. It won't go straight. It'll continue on in a circle. But that's a good explanation for why we don't fly off the Earth, right? So we're already in circular motion, and that's why we don't zoom off. It's incorrect. Like, so he gives this wacky new version of physics. So, okay, people come to him with this really devastating objection to the Copernican picture. Devastating. Look, I know how spinning around in a circle works. You're telling me that we're spinning around in a global circle? They're like, well, here's my new theory of physics that makes that okay. It's an incorrect theory of physics, by the way. That's not how physics works. Things tend to continue on in a straight line if uninterrupted. So Galileo gets this through by an ad hoc. He makes up a new theory that's wrong to explain the clear problems in the theory he's defending. Just like a good scientist would. Yeah.
It's wrong, but it's closer to reality than the previous theory.
Fair. That's fair. Yeah. So wrong in a productive way, you might say.
Yes.
So the lesson Feyerabend would have us learn is be wrong in useful ways.
Or like attempt not necessarily truth, but just increasing accuracy.
Maybe, yeah, yeah. I once had a famous philosopher tell me after a talk that he thought my idea was interestingly wrong. And I thought that was the best thing that could have happened to me. I'm like, yes. All right, okay, good. Okay, so lack of stellar parallax, problems with inertia. It looks like what Galileo's doing, we discussed before, ad hoc hypotheses. So this is what you do. So Popper says when you got a bad theory, what you do is add in ad hoc hypotheses. Sorry, it was my Belvillian up. I grew up in Belleville, so that's how we talk there. Ad hoc hypotheses to fix up your theory. That's what a bad scientist does. And if you're doing that, you're acting in bad faith. Like you're being a bad scientist. But here's Galileo, possibly, like he's regarded as one of the best scientists ever, and he unquestionably makes huge. I'm being hard on Galileo. He unquestionably makes enormous contributions to physics and astronomy and math. So what Feyerabend says about these cases is that ad hoc hypotheses can give a new idea space to breathe. And that's exactly what it did for Galileo, right? The Copernican view just had to have enough time for somebody like Newton to come along to come up with the theory of inertia that we're kind of familiar with. Things in motion tend to stay in motion in a straight line. So Newton can sort this stuff out. But Newton doesn't come along for quite some time. And these ad hoc hypotheses keep the heliocentric, the sun-centered picture of the solar system alive long enough for somebody to figure it out. Right? So you've got devastating, devastating objections to your theory, but don't give up on it. Like Popper would have, that wimp Popper would have you just give up. Don't give up. Come up with some ad hoc hypotheses. Patch things up for long enough to keep your ship afloat, and then you'll come up with something. Come on, have some spine, right? Furthermore, he's using radically unconfirmed methods. So he made these telescopes. Hey, look at this, look through this instrument that I made myself. It will change your view of the world. Cool. How does it work? I don't know. There's no good theory of optics at this point. We haven't quantified it. Again, Newton comes along and does really good work making optics more a science or more an accurate science. There's no good theory of optics right now. And his telescope was not awesome. So when the Medici, so Galileo is making these claims about the Medici stars, the claims that he's staked his reputation on. So he's really putting his neck out. So he's passing around the telescope, being, look, you can see them for yourself. And a group of these courtiers goes out, looks through the telescope, and at the end of the night, they're still arguing about what they saw. Like, these are not awesome telescopes. These are not telescopes where you just look through it and you're like, oh, it's very obvious what I'm looking at. It's fuzzy, it's distorted, you have to hold it just right to see anything. So these are like low quality telescopes. You couldn't buy a telescope this bad today. They're very unreliable, they don't know how they work, it's totally new technology, unconfirmed methods. to make these groundbreaking claims. But he's right. So, and furthermore, Feyerabend wants us to take from this story that you shouldn't always rely on argument. Arguments are fine. There's nothing wrong with arguments. But don't be a slave to argument. Sometimes you need to persuade people rhetorically. You need to tell really good stories. You need to convince them by being, you market your ideas. You need marketing. Yeah? And Galileo was a consummate marketer. He was really good at selling his ideas. And honestly, I can't escape, as much as I might doubt parts of Feyerabend's argument, I can't escape the idea that Galileo, being a good marketer, set science ahead by decades or centuries. He sold the idea. This Copernican picture that was languishing, some nerds knew about it, but he brought it into the world by being good at selling it. Yeah? Unfortunately, this is also what got him into trouble. He's really good at selling ideas, but he didn't know when to back down. So in the most famous book where he's defending the Copernican worldview, this is the one that kind of got him in trouble. After the Pope had kind of told him to lay off this Copernicus stuff, the Pope said, you can talk about this, but don't say it's real. Yeah, it's a hypothesis. It's a good mathematical model. It's interesting. We should continue to cultivate it. Just don't say it's real. He writes this dialogue. And again, the scholastics, the people in the universities are writing these unbelievably boring, plodding, pedantic treatises. They're just saying what they think is true in unimaginably boring detail. Galileo writes a fun dialogue. It's written in the vernacular, so non-scientists can read it. You don't have to be a specialist. The problem was that it's a dialogue between Salviati, who's obviously Galileo, Sagredo, who's just sort of a neutral, listening guy, and Simplicio, a dogmatic Aristotelian who's representing the view defended by the church. And Galileo claims that Simplicio is not supposed to sound like simpleton, but it does. And he's obviously sort of meant it to be look at this, this is the simpleton who's representing the church's view. So he's really thumbing his nose at the Pope at this point. And it's a fun rhetorical technique. It did convince people, but he's being, and Simplicio comes off in this dialogue as a bit thick. He's not that bright. And he's standing in for the Pope, which turns out to have been a bad move. And of course, Galileo was against the standing up to the key elements of the Aristotelian worldview. But I want to emphasize that Aristotle wasn't just this picture of the solar system. It was a highly integrated and very well-developed picture of everything from, the solar system. There's physics, there's biology, there's geology. So trying to explain why there are the minerals where they are, right? So this whole story about how the Earth develops and changes, how our place in the universe matches up with the way we understand it. So epistemology, psychology, sociology, this is all intensely, deeply integrated into this really robust worldview that's been developed for centuries or millennia by a huge number of people. And Galileo is proposing to knock out some really key elements of it, but he's not giving us a replacement for any of that other stuff, right? There's nothing to say about geology. He's not a geologist, that's not his interest. There's nothing to say about biology. So he's proposing to trash this theory without explaining a whole bunch of the things that it was developed to explain. It's look, I saw 4 things going around Jupiter. Aristotle's wrong. So he's going against very well-confirmed theory, well-established theory, we might say, without purporting to be able to explain a whole bunch of the things that the well-established theory purported to explain. Which is why the Feyerabend thinks at the time the church was very reasonable to say, Galileo, you're out to lunch. Now, the bit that you probably have heard before was Galileo was put on trial by the church because the Bible says that the Earth is in the center of the solar system, and they couldn't move off that party line. So here's a couple passages from the Bible that were the most sort of at issue. Tremble before him, all the earth. Yes, the world is established. It shall never be moved. Or the sun rises and the sun goes down and hastens to the place where it rises. So those make it sound like the earth is standing still and the sun is moving. But I'd like to emphasize, I don't find myself in the position of defending the Catholic Church very often in my day-to-day life, but here we go anyway. The Catholic Church saw it as their main job to interpret the Bible for people. The idea that people are supposed to have a kind of personal relationship with Scripture, that it's up to you to read it and understand what's in it, that's pretty new. That's after the Protestant Reformation. And it's certainly, that's the thing that everybody sort of left the Catholic Church for. The Catholics believe they're the ones who have read the whole thing and thought really hard about it for like 1,500 years. So they're the ones who are supposed to be interpreting it. They're the only ones who know Latin. So the Bible's at this point in Latin. Y'all don't know Latin. They do. Their job to figure out what's in the Bible for you. So they really easily could have decided, and eventually did decide, that we're going to reinterpret. The Catholic Church, that's still in the Bible, they're not geocentrists anymore. They just reinterpreted these passages. The Jesuits are really, really smart. They can do that. And they've done it historically over and over and over again. Like, it's not hard for them to fit heliocentric model of the solar system into their religious worldview. The Catholic Church is awesome at this, and they consider it one of their main jobs to interpret the text for you, rather than you interpreting them yourself. That's a Protestant thing. So they easily could have fit this. It wasn't like they were so dug in on this issue that they had no room to move. The issue was the arguments for heliocentrism were really bad. They went against everything that scientists at the time believed. And furthermore, Galileo was being kind of a jerk about it. And you don't be a jerk to the Pope, even if you're kind of friends with him, which he was. So in 1616, he's put on trial. At that trial, the church says, it's fine for you to talk about this stuff. Just present it as a hypothesis, not as a fact. Galileo goes on his merry way, talking about it as a fact. And then he gets to have another trial in 1632. And the main issue at that second trial was not, is the sun at the center of the solar system? It was, did Galileo do what we said the first time? They might be flexible on the structure of the solar system. The Catholic Church is red hot on whether you did what they said or not. So if you don't do what they say, they are really interested in that. Flexible on astronomy. So what they decided in this 1632 trial was that he hadn't obeyed their first decision. And they put him under house arrest in his villa in Tuscany with his servants and his nice food, and he wrote a couple more books. Yeah, so that was the wrath of the Catholic Church at that point. Other people were horribly tortured for being mouthy to the Catholic Church, but Galileo was definitely not one of them. Anyway, okay, so back to Feyerabend. The lesson that he wants us to take from this story is that Galileo broke the rules. Galileo did stuff that any respectable philosopher of science, which of course Feyerabend does not consider himself one, would tell you is against the scientific method. That's bad science. You don't try to overturn an extremely well-integrated and well-established scientific theory with your bonkers new instrument that you made up. You don't produce ad hoc hypotheses to paper over the holes in your theory. You don't use techniques of popular persuasion rather than rigorous arguments aimed at the experts, right? What you do as a respectable scientist, of course, aims their argument in the most technical and precise detail to the relevant experts. They don't try to talk to people who cares what people think, right? That's the scientific method. Galileo did none of that. Galileo broke every single one of those rules. And it's hard to find somebody who's willing to come to bat to say that Galileo was not a good scientist. I don't know anybody who would. And actually, the reviews of Against Method are funny because some people were worried about was that Feyerabend was being unfair to Galileo. They say, no, he was actually really rigorous and really careful. So Feyerabend might have been exaggerating the degree to which Galileo breaks the rules. But I think it's pretty clear. He makes a decent case that Galileo was not acting in the way that we expect respectable scientists to act. Therefore, do whatever you want. Hooray. Okay. So, what do you think? Are you convinced of epistemological anarchism? That everybody should just break the rules whenever they feel like it? Yeah, all right, good. Anarchy forever, great. Yeah.
I mean, you can make the argument that humans are slowly moving towards an anarchist society. And so, like, this is
Really?
Yeah.
Because my phone just recorded you saying that and will provide products for me based on it later.
But how? Wait. How does that go for or against anarchism?
Well, there's a centralized control that economically benefits from that and is deciding how we behave in its benefit.
For now.
Yeah. Okay. Okay. Let's leave aside political anarchy because that's not the thesis under consideration, and I'm wildly unqualified to talk about it. I have no background in this. I can talk about epistemological anarchism just fine. I have no basis on which to discuss with you political anarchism. Yeah.
I think that people should probably try to follow better established knowledge and methods and whatever but if you hit a point where you have a conviction about something but the rest of the world is kind of coming back at you, then you need to stop back and think about that and decide if it's warranted to break the rules.
Right.
And if so, then I say go ahead.
So, yeah. Does that sound right to everybody else? Yeah.
I mean, break the rules has worked pretty well in the past. It's not gonna benefit us again.
Yeah, that's the lesson, that's the moral of the story of Galileo, is that sometimes breaking the rules really pays off, not just for the individual, but for humanity as a whole. Like, science was advanced, clearly, by this egregious rule breaking. Yeah.
I think the detriment of accepting what Ryan said is that as soon as you allow, if you have enough conviction, and you honestly believe that you are going to create novel, if you're going to create novel predictions, you think that this is something that is legitimate, and you're going to say, I have some sort of reason to break the rules, then everybody who is a scientist who wants to be treated seriously is going to think, well, I think everybody's going to, we've learned all about this throughout the entire class, that people who are doing their predictions and trying to create scientific results are convinced about the results. They're trying to, and they're biased.
So Feyerabend has a response to this. I'm not necessarily endorsing it, but I want to tell you what it is. He says, don't worry about that, because the human brain is too set up to be like rule followers that our natural proclivity is just to do what everybody else is doing, and B, what we've been told to do. So he thinks we're kind of wired up to be slightly conformist, and that endorsing something like epistemological anarchy is you're just seasoning the knowledge production process with a little bit of anarchism, and that'll improve things. And don't worry about it flying off the handle with everybody acting bad because we're just sort of naturally predisposed to be rule followers.
For every Galileo, there's a bunch of people out there that thought a thought that they're like, oh, that's a cool thought, and then they're like, nah, that's scary.
Yeah. I have certainly found myself at 2 a.m. standing at a stoplight with no cars and just watching it, waiting for it to turn. So I know that I have this rule following thing in me,
Okay, I can Galileo.
I don't know.
Definitely not.
So epistemological anarchism doesn't say you're allowed to, I guess it does sort of say that you're allowed to manipulate people. We started off talking a lot about the kind of scientific fraud and how that's a thing. I'm not sure, I guess it's, he's got to be okay with, if anything goes, then cynically manipulating the data to get yourself a grant has got to be a thing that goes, right? Yeah. Oh, sorry. Yeah.
I think it's true that this dispersion that comes through Kuhn's theory, and it's not really keep think of it that way. Like you don't need to go to extreme.
Right.
Not for like sometimes you need to.
Good, good. Okay, so Kuhn maybe gives us a more moderate version of this, where there's no rule that you can't think of revising, but so that's very good. One of the tensions between Feyerabend and Kuhn is Kuhn thinks scientists should mostly participate in their paradigm. Like once you've got a community that's acting in some way, you're mostly supposed to go along with it. And the decision to break the rules is more of a collective decision. Whereas Feyerabend thinks that individuals should go and do whatever they want. So maybe that's part of the tension that's there. And certainly more moderate, Kuhn's view is certainly more moderate. You might want to get some other people on, before you decide to start breaking rules, maybe get some other people on board, try to build a group, try to build a coalition kind of thing. We're certainly more effective in groups. Groups get more done than individuals do. You don't want to be alone. You might get banished to your Tuscan villa. Yeah, yeah, good, good. Okay. Well, let's let that stew. Well, I'm happy to talk more about this. I would love to see essays about it when we're done the semester. But yeah, let's leave it there. I don't really know what I think about this. I think it's super interesting to think about. Anyway. Okay, so that's it for today. Next time we'll do some stuff on social construction.